Can we travel faster than light? Science fiction loves to speculate about this because warp speed, as faster than light travel is popularly known, would allow us to travel between stars in time frames otherwise impossibly long. And while it has not been proven to be impossible, the practicality of traveling faster than light renders the idea pretty far-fetched. In today's episode, we break down the universal speed limit c equals 186,000 miles per second. The speed of light isn't just about the speed limit of light. Not only is it the speed at which massless particles travel through a vacuum, it's the speed of causality, the limit of which any amount of energy can traverse through space-time from point A to point B. You can think of it like a row of dominoes. You hit the first domino and wait for the energy to run through the line until it finally hits and knocks down the last one. What can't be done is hitting the first domino and getting the instantaneous reaction from the final domino. In the universe, there is no such thing as instantaneous. What we're discussing is communication. If I picked up a radio and sent a message to someone on the surface of Mars, it would take time before the signal can reach the receiver at its destination. It generally takes about 5 to 20 minutes for a radio signal to travel the distance between Mars and Earth, depending on the planet positions. The speed limit that everything in the universe must adhere to, or the universal constant, is about something much deeper than just the speed of light. The speed of light should really be called the speed of causality, causality being the relationship between cause and effect. Another way to think of causality is in relation to a concept known as the space-time interval, which states that causal connections are the only order of events that all observers, from wherever they're positioned in the universe, can agree on. In the theory of general relativity, the concept of causality is generalized in the most straightforward way. The effect must belong to the future light cone of its cause, and if the space-time is curved. New subtleties have been taken into account when we investigate causality in quantum mechanics and relativistic quantum field theories in particular, however. In quantum field theory, causality is closely related to the particles of locality. However, the principle of locality is disputed whether it strictly holds depending on the interpretation of quantum mechanics chosen, especially for experiments involving quantum entanglement that satisfy Bell's theorems, but I'll leave that for a future episode. Despite all these subtleties, causality remains an important and valid concept in physical theories. For example, the notion that events can be ordered into causes and effects is necessary to prevent or at least outline causality paradoxes such as the grandfather paradox, which asks, what happens if a time traveler kills his own grandfather before he ever meets the time traveler's grandmother? There are many other important reasons that causality is deeply ingrained into the fundamental laws of nature. The chronology protection conjecture is a hypothesis first proposed by Stephen Hawking, that the laws of physics prevent time travel on all but microscopic scales. The permissibility of time travel is represented mathematically by the existence of closed time-like curves in some solutions to the field equations of general relativity. We are of course talking about time travel to the past. See my video on special relativity for more information on time travel to the future. You can click on the annotation and I'll leave a link in the video's description. As we can see, the speed of light, or the speed of causality, isn't just a trivial number. Its significance is far broader than its role in describing a property of electromagnetic waves. It serves as the single limiting velocity in the universe, being an upward bound to the propagation speed of signals and to the speeds of all material particles. Unfortunately for us, there will be no faster than light travel through space-time anytime soon, and likely, never. I very much appreciate everyone. As always, thank you for the support. It's been fun and certainly challenging making these videos. I find beauty in science. I'm really passionate about it and I love sharing it. If you like what you saw, please consider subscribing. Bye guys.